Hello everyone. My name is Rupasri and I am from 2CSCD. Now we are going to discuss about priority scheduling in operating system. Let us see what is a priority scheduling. Priority scheduling is a method of scheduling process that is based on priority. In this algorithm, the scheduler selects the tasks to work as per the priority. That means if there are n number of process are coming into the CPU, then the process will be executed based on some priority value. Here, the highest priority value will be executed first, and the low priority will be executed last. And the process is having equal priority. For example, if two processes having equal priority, then these will be executed based on either round robin or first come first serve basis. In round robin, we will place them in ready queue and we'll use the time quantum, whereas in first come first serve, the process which come first will be executed first. So see here, the scheduler selects the tasks to work as per the priority. As we have already discussed, the processes with higher priority should be carried out first, whereas jobs with equal priority are carried out on a round robin or FCFS basis. Priority depends upon memory requirements, time requirements. There are two types of priority scheduling. The first one is preemptive scheduling, and the second one is non-preemption. What is the difference between the preemption and non-preemption schedulings? We'll see in detail here. In preemptive scheduling, the tasks are mostly assigned with their priorities. Sometimes it is important to run a task with a higher priority before another lower priority task. If a lower priority task is still running, the lower priority task holds for some time and resumes when the higher priority task finishes its execution. When it comes to non-preemption, in this type of scheduling method, the CPU has allocated to a specific process. The process that keeps the CPU busy will release the CPU either by switching context or terminating. It is the only method that can be used for various hardware platforms. That's because it doesn't need special hardware. For example, a timer, like preemptive scheduling. It doesn't need any special hardware, just like in the which we are using in the preemptive scheduling. Let us see the characteristics of priority scheduling. The first one is a CPU algorithm that schedules processes based on the priority. And the second characteristic of priority scheduling is it is used in operating system for performing batch processes. If two jobs having the same priority and they are ready, it works on first come first serve basis. As we have already discussed in the previous slide, that if two processes are coming to the CPU with same priority, then these will be executed based on first come first serve basis or round robin basis. So in priority scheduling, a number is assigned to each process that indicates its priority level. So when we are using the priority scheduling, we have to assign a priority to each process. That priority should be always be in a number. So lower the number, higher is the priority. That means if the process is having, if two processes are there, one is having the priority number 1 and another is having 14 as priority, lower the number, higher is the priority. That means the first P1 will be executed, which is having the priority number as 1, and the P2 will be executed later, which is having the priority number as 14. In this type of scheduling algorithm, if a newer process arrives that is having a higher priority than the currently running process, then the currently running process is preempted. That means in CPU, we get many processes with higher priority or lower priority. If, for example, a process is already in CPU with some priority and that higher priority process is occurred, then that process will be preempted and allow the other process to execute. This is called preemption, as we have already discussed in the previous slides. Let us see the advantages of priority scheduling. Here are the benefits of priority scheduling. It is easy scheduling method. The second advantage is processes are executed on the basis of priority. So high priority does not need to wait for long, which saves our time. This method provides a good mechanism when the relative importance of each process may be precisely defined. And another advantage of this is suitable for all applications with fluctuating time and resource requirements. And when we are having the advantages of priority scheduling, we also have disadvantages regarding this. So let us discuss in detail. These are the drawbacks of priority scheduling. Let us discuss in detail. If the system eventually crashes, all lower priority process will get lost. If higher priority process takes lots of time, then the low priority process may stop, will be postponed for an indefinite time. That means if the higher priority process taking more time to execute, sometimes the lower priority process may not get the chance to enter into the CPU and to enter into critical section. So they may stop. So that in sometimes an infinite loop, that means they cannot be executed and they will go into deadlock state even. So this is the disadvantage. This scheduling algorithm may leave some low priority process waiting indefinitely. A process will be blocked when it is ready to run, but has to wait for the CPU because the other process is running currently. If a new higher process keeps on moving in the ready queue, then the process which is in the waiting state may need to wait for a long duration of time. As we have already seen in the previous disadvantage, that if the higher priority process keeps on executing and coming into the ready queue, then the lower priority will be in the waiting state and for longer duration, and this may causes for starvation. Thank you.